Okay, we're going to do some more logarithmic equations, and we did A and B, and those were kind of easy. Now we're going to do part C, and we're going to kind of review. Remember when we looked at this back when we did part, I guess, B, we noticed that if we had, because these logarithms are one-to-one, that means if for each domain we've got one range, and for each range we've got one domain element, range being the vertical position, the domain being the horizontal position. This is actually the log. This would actually be y equals log base 2 of x, that actual function. So if we have a situation where this, which would be the range element, equals this range element, then the domain elements must be the same. So if we've got log the base 2 on one side equals log the base 2 on the other side, then the domains would be equal. So we can just write a simple equation, x plus 3 equals 5x minus 5. That would be easy to solve. This was another example. Same base, same log, so this range element equals that range element, so the domain elements are the same. So we can just come up with this equation here. Now what happens if we've got more than one log? Well, we can't do it. It has to be one log on the left, one log on the right. One range element to one range element equals one domain to one domain. All right? This whole thing would be the range. These would be the domain elements. So let's take a look at an equation like this. And we see that we've got two logs on the left, one log on the right. So we've got to get one log. So what we're going to do is we're going to just condense this. And we've got a difference, so we know the difference of the logs is the log of the quotient. So we'll write this, we use our quotient rule. This would be equal to log to the base A of some quotient. In this case, it's going to be 3x plus 5 all over x minus 5. And that's going to be equal to log to the base A of 8. And now you can see you got one log on the left, one log on the right. So if the left equals right and the base are the same, and the range elements, the domain elements are the same. So we can rewrite this equation as 3x plus 5 over x minus 5 equals 8. In other words, if the left side equals the right side, then these have got to be the same. Now, as long as x is not equal to 5, because we can't have 0 in the denominator, we can multiply both sides by 5, and we can rewrite this equation as 3x plus 5 equals 8 times x minus 5. Just multiply both sides by x minus 5. If you need to see that, I can write it over here. X minus 5 on the left and x minus 5 on the right. And x minus 5 over x minus 5 is 1. Then I can distribute, and I've got 3x plus 5 equals 8x minus 40. I can subtract 3x from both sides. So I have 5 equals 5x minus 40. Then I could add 40 to both sides. So I have 45 equals 5x. And then I could divide both sides by 5. And x equals, and 5 goes into 45 9 times. I always want to check your answers on these. That's real easy to check if I put, well, I'd have to put it in here, so it's not so easy to check. But we always want to put these numbers in because we want to make sure that these are always positive. Okay, remember, if we go back and look at our properties of logarithms, all right, the domain has always got to be positive. It says for x greater than 0, and this is the domain element. And again, when we graphed it, we can look at it in its basic form. You can see that the domain is always, it's from 0 to positive infinity. In order to really check it, we'd have to put it in over here. But the real check you want to do is make sure that this is always positive. So if I put 9 in here, that's going to be positive, and that's going to be positive, so we're okay. All right? Okay, let's take a look at another example. Now this has got several little complications to it, which makes it a very interesting problem. So first of all, we've got two logs on the left, so we want to consolidate this, but we got a 1 on the right. Now we want to have everything to be log to the base 6, so how can we write this? Well, what you can do is we can say, well, what we want is we want log to the base 6 of something. Now, I don't know what that something is, so I can call it x, but I want it to be equal to 1. So instead of writing 1, I can write log to the base 6 of that something. And then I'll have log to the base 6 on both sides. Now, if we want to find out what this is, all right, we can just solve this exponential equation. What's my base? 6. What's my exponent? 1. What's my answer? X. So what would x be equal to? Just 6. And that kind of makes sense because log to the base 6 of 6 equals 1. In other words, this is the exponent that when I raise 6 to it, I get 6. Well, 6 raised to the 1 is 6. That makes sense. So instead of writing this as 1, I can write this as log to the base 6 of 6, because that's equal to 1, you see. So I'll rewrite this over here as log to the base 6 of x plus 1 plus log to the base 6 of x, and equals log to the base 6 of 6, which is the same thing as 1. Now I've got everything in log to the base 6. And again, we've got 2 logs on the left, so we want to consolidate this. So we'll use our product rule. So this would be log to the base 6 of a product. And that product will be x plus 1 times x. This is my product rule, and that equals log to the base 6 of 6. And now we know if the range elements are the same and the domain elements are the same, or if the left equals the right, then these are the same. So I could say that x plus 1 times x equals 6. And then we have a nice equation to solve. So let's work this out. So we'll multiply this out. So we get x squared plus x equals 6. And we've got a quadratic equation, so we have to set it equal to 0. So I'll subtract 6 from both sides. So x squared plus x minus 6 equals 0. We've got 3 ways to solve a quadratic equation. We can either factor it, complete the square, or we can use the quadratic formula. In this case, I think I can factor this. It looks like a simple trinomial. This tells me my signs here are different. This tells me these signs here are different. This tells me the sign of large, so I got positive, negative. Multiply to give 6 and differ by 1, 3 and 2. So those are my possibilities. So I know that if 2 things multiply to give 0, either one or the other or both must be 0. One or the other, both could be 0. So x plus 3 equals 0, or x minus 2 equals 0. And if I subtract 3 from both sides, x equals negative 3, or x equals 2. Now I've got to check these. And remember, we want to make sure that our domain is always positive. So if I put negative 3 in here, what's negative 3 plus x? That's negative 2. That's not going to go. So negative 3 will not work. To cross that out. It doesn't check out. Because remember, my domain is always positive. My domain element must always be positive. I put it in here, definitely going to be negative. Now, how about if I put 2 in? Well, what's 2 plus 1? 3, so that's okay. And 2 is definitely greater than 0, so that's okay. So 2 works, so there's my solution. That's my solution set, so to speak, or x equals 2 is the solution. So you have to check these. And remember, the domain element must always be positive. Minus 0 won't cut it. So hope those help.